Dear students, in this session, we are going to discuss about elementary particles and their classification. So, the matter in this universe is supposed to be made of microscopic elementary constituents, and these particles are known as elementary particles. In the earlier decades, the physicists thought that the ordinary matter is composed of protons, neutrons, and electrons, and these particles account for the structure of the universe around us. But later, with the discovery of quarks, it is clear that the quarks and leptons are the fundamental or elementary particles. So, what are the properties of elementary particles? Or what do we mean by an elementary particle? Elementary particle or fundamental particle is the one which is not a composite of others. That means it has no internal structure. Its internal structure cannot be described as a combination of other particles. In the early 30s, people knew about only 4 elementary particles, which are electron, proton, neutron, and photon. But later, it is discovered that protons and neutrons are again composed of quarks or made up of quarks. So quarks are the basic or fundamental particles. And later, with the discovery of or with the advancement of particle accelerators, the elementary particles were more discovered, and their discovery of elementary particles number grown to 14 in 1947, and by 1957 it reaches 32, and by the recent discoveries of elementary particles in the accelerators like Large Hadron Colliders of CERN, there are many particle accelerators working all around the world, and so much elementary particles are discovering nowadays. So this is a recent blooming branch of physics, high energy physics. So what are the properties of elementary particles? Elementary particles are the ultimate building blocks of particles. That means all the particles in the universe or all the matter in this universe is composed of elementary particles. So they are known as the ultimate building blocks of particles. Next property is they are structureless. That means they cannot be explained as a system of other particles. So, as they have no structure, they are point-like particles. And these elementary particles are characterized by some features. They have mass, electric charge, spin, lifetime. So, they are characterized by these properties: mass, electric charge, spin, and lifetime. Okay, so let's see the properties of elementary particles. First one is mass. An elementary particle has always the same rest mass. The magnitude of rest mass is the identification or unique feature to identify a particular particle. So the identity of an elementary particle is its mass. Next one is charge. All elementary particles have either positive charge or negative charge or zero. That means the charge is expressed in units of E. E is the basic unit of charge, 1.6 into 10 raised to minus 19 coulomb. So all elementary particles have charge based on this either positive, negative, or zero. And the main property of this charge is that charge should always conserve in any collision or decay process. That means a charge should be conserved in all nuclear process or all the process, or process means either reaction or decay. So let's see some examples here. So this is a reaction. So what is the difference between a reaction and a decay process? We are usually coming across 2 types of process in nuclear physics. First one is reaction and second one is decay. What is the difference between reaction and decay? Reaction means we have two or more reactants, like A plus B. A and B are the reactants, and this reaction will lead to 2 or more products. So A plus B gives C plus D is a reaction, and in this reaction the participating reactants are A and B, and the products obtained after this reaction is C and D. So this is one process. Okay. Next one is decay. So what do you mean by decay? Not all elementary particles are stable. Only few elementary particles are stable. All other elementary particles will decay into some other elementary particles. Sometimes its lifetime is very small. They will rapidly decay into some other particles. So these elementary particles are always created in high energy collisions. So these high energy collisions are happening in this particle accelerators, and during these collisions, many elementary particles elementary particles have been discovered, and all of which will rapidly decay into some other particles. So the decay process actually means that one elementary particle can decay into several products, B plus C, or like that, B plus C plus D plus etc. So if one element is decaying into many products, it is known as decay process, and if two or more reactants entering in a reaction will lead to products, then it is called a reaction. So this is the difference between reaction and decay. So here this is a reaction. Here the reaction is N indicates neutron and P indicates proton. So neutron-proton collision is happening here. In the neutron-proton collision, as a result of this collision, we get the following products: proton, proton, and this is known as pion. We will come in detail later. So just to see the charge of these elementary particles. We know that the neutron is a neutral particle, so it has charge 0. Proton is a positively charged particle and its charge is 1. 1 plus E, that means I am only taking the magnitudes, so 0, 1. Now here in the right side, RHS, we have proton charge 1, proton charge 1, and pi minus, so its charge is negative 1. So in the LHS, the total charge is 1. In the RHS, total charge is 1 plus 1, 2, 2 minus 1, 1. So in the LHS and RHS, the charges are same. Or we can say that the charges in the RHS minus charges in the LHS is equal to 0. That means no change in charge after the collision process. Before collision, the total charge is 1, and after collision, charge is 1. So we can say that in this collision process, the charge is conserved. Similarly, we can see the next case. In the next case, see the neutron and proton will lead to some other products. So in this collision, it will cause the formation of two neutrons and a positive pion. So here the neutron has 0 charge, proton has 1 charge, neutron has 0 charge, neutron has 0 charge, and pion has positive 1 charge. So before collision, total charge is 1, and after collision, total charge is 0 plus 0 plus 1, so 1. So this means that in this collision also, the charge is conserved. In the final collision, in the same collision between neutron and proton, in the final step we have neutron, proton, cation. K is cation, K minus and K plus. Both are cation family, the K minus cation and K plus cation. So here the N has 0 charge, proton has 1 charge, N has 0 charge, proton has 1 charge, minus 1 plus 1. Okay, so the total charge in the left is 1, total charge on the right is also 1. So this is also conserved. So we can say that if the charge is conserved, these processes these collisions are allowed. So conservation of charge is a method to check whether a reaction is allowed or not. So how we can check that if in a particular reaction or in a particular collision, if the LHS has, or suppose in the LHS we have total charge 1, and the RHS we have total charge 2. Here the charges are not same after and before collision. That means charge is not conserved. If so, that reaction is not allowed. That means that reaction cannot occur. It's not possible to occur. So suppose in the university exams you have some questions like this. Say a particular reaction is allowed or not. Check whether a particular reaction is allowed or not. So how we can check that? Only one method is conservation of charge. We have to check several other categories, and if all conservation laws are valid, then we can say that that particular reaction is allowed. or otherwise it is forbidden. Okay, so one method to check whether a reaction is possible or not is to check the conservation of charge. I think this is clear to you. So this is an important step. We will come in detail about this conservation of charge later. So next property of elementary particles is lifetime. All elementary particles except photon, electron, proton and neutrinos are unstable. That means only photon, electron, proton and neutrinos are stable elementary particles or stable particles. So except these particles, all the elementary particles are unstable. So they will decay rapidly into some other elementary particles of smaller mass. Usually, an elementary particle of heavy mass will decay into other elementary particles of small mass. That is a usual procedure. If a particle has high mass, it will decay into less mass particles in the decay process. So later we can see that in classification of particles we can see the lifetime, mass and spin of all particles. Okay. So fourth property is spin. So the spin of the particles can be categorized into half integral and integral. So if the particle has half integral spin, so what do you mean by half integral spin? So spin is always expressed in terms of, spin is actually the spin angular momentum. Intrinsic spin angular momentum we are discussing here. So it is always expressed in terms of h cut. So here we are taking only the magnitude. So if the spin is like half, 3 by 2, 5 by 2, etc. like that, these spins are called half integral spins. These are half integers. So these spins are known as half integral. So if the spins are half integral, if the particles have half integral spins, then such particles obey particular statistics. And this is known as Fermi-Dirac statistics. Fermi and Dirac are famous physicists. So in terms of they put forward or postulated this statistics. In statistical mechanics, we will come in detail about Fermi-Dirac statistics. And the particles obeying Fermi-Dirac statistics are called fermions. Okay, so these are important points. So based on the spin, we can classify particles into two types. First one is fermions, and second type of particles are known as bosons. They are known as bosons because they obey Bose-Einstein statistics. So Bose-Einstein statistics have zero or integral spins. That means 0, 1, 2, etc. So they have integral spins. So bosons have integral spins. That means 0, 1, 2, etc. 3, etc. Like this integral spins. But the fermions have half integral spins. Okay. Now examples of fermions are electrons, positrons, protons, neutrons, neutrinos, antineutrinos, mesons, hadrons, etc. And bosons examples are photons, gluons. You can see that all the field bosons we have studied in the interactions, fundamental interactions. We have learned about field bosons. What are the field bosons? Field bosons in the case of gravitational interaction is graviton. Strong interaction, gluon and meson. Similarly, in the case of electromagnetic interaction, it is photon, and in the case of weak interaction, W and Z bosons. All these are bosons. So they are known as bosons because they have integral spins. Okay. So based on spin, the particle can be classified into two categories: fermions and bosons. Fermions obey Fermi-Dirac statistics, and bosons obey Bose-Einstein statistics. Fermions are half integral particles, half integral spin particles, and bosons are zero or integral spin particles. And we can see several examples here. So these are the characteristic properties of elementary particles. First one is mass, second one is charge, third one is lifetime, and fourth one is spin. Next, we are going to discuss about antiparticles. If you can see that for all elementary particles, we have antiparticles. For all elementary particles, we have antiparticles. What do you mean by an antiparticle? Antiparticle of a particle have same mass, spin, lifetime, but its charge has opposite sign. So we have discussed about four characteristic properties: mass, spin and lifetime. Mass, spin, lifetime and charge. Except charge, all other parameters are same for for antiparticle. So and the next opposite case is spin and magnetic. It's more magnetic moment. That means alignment between its spin and magnetic moment is also opposite. Okay. So these are the differences between particle and antiparticle. So for every particle we have an associated, each elementary particle has an associated antiparticle. Antiparticle has same mass and spin but opposite charge and magnetic moment. For example, you can see that the positron is the antiparticle of electron. So how we can represent positron? Electron we are known as, we are familiar with electron. Electron is represented as E minus. This is the symbol of electron. So the corresponding antiparticle has the same symbol E, but the charge is opposite, E plus. So E minus represents the electron and E plus represents its antiparticle, that is positron. Okay. So here you can see that both has same mass and spin, but the positron has positive charge and electron has negative charge. So they have opposite charges. And if this is a famous reaction, this is known as annihilation reaction or annihilation process. So if an electron collide with a positron, they will annihilate and it will lead to the generation of or the transformation of this mass of these two particles into two gamma rays, and this process is known as annihilation process. So this is a famous process. This is the opposite process of pair production. So opposite of pair production is pair annihilation. So this is one example for particle-antiparticle interaction. And next one is antiparticle of stable particles. Antiparticles of stable particles such as not positron, proton and antiproton. Not positron here, proton. We know that proton is a stable particle and its antiparticle is known as antiproton. So proton's antiparticle is known as antiproton, neutron's antiparticle is known as antineutron, electron's antiparticle is known as positron. Here proton is a stable particle, so its antiparticle is also stable. So the antiparticles of stable particles are always stable. Now, when a particle meets its antiparticle, then what will occur? An annihilation reaction can occur. So that is given here. When E minus and E plus will meet, then they will cause the vanishing of these two particles, these two particle and antiparticles, and instead of that we can have two or more photons according to their mass. Carl Anderson discovered positron and marked the discovery of first antiparticle discovered as positron by Anderson, Carl Anderson. Okay, so this is about antiparticle. Next one is antimatter. So antimatter composed of, we know that matter is composed of what all things? Protons, neutrons, electrons, quarks, etc. Similarly, antiproton composed of all the antiparticles. Antiparticles like antineutrons, antiprotons, positrons, like that. Okay. So just like ordinary matter, antimatter behaves exactly like the ordinary matter. So we can say if there is a matter of if there is stars, correspondingly there is an antimatter stars will exist inside the galaxies, and we can see that their spectra cannot be different from the spectra of matter stars. So the difference is only in the charge. And how we can distinguish between these two galaxies, the galaxies of antimatter stars and galaxies of matter stars. So for that, the requirement is that antimatter from one galaxy should come in contact with matter from the other galaxy. Then only some interactions will occur, and it will result in the products. And by analyzing the products, we can say that one is antimatter and one is matter. Okay. So the matter is composed of all particles and antimatter is composed of all antiparticles. And in this case also mutual annihilation will occur when the opposite particle and antiparticle will meet. Next is the important step in this elementary particles, that means classification of fermions and bosons. We already discussed about what do we mean by a fermion and what do we mean by boson. Fermions are half integral spin particles and obey Fermi-Dirac statistics, and bosons are integral spin particles and they obey Bose-Einstein statistics. So let's see the classification of elementary particles based on the spin. So we can classify particles based on many properties, based on their charge, based on their spin, based on their mass. So here the basic classification is based on one of the property, that is spin of particles. So we can classify elementary particles into fermions and bosons based on their spin. So in the fermions we have two categories, leptons and baryons. Leptons and baryons. Some examples for leptons are electrons, positrons, and an electron neutrino, that is represented as mu e. And similarly, in the case of baryons, they are a neutron, proton, sigma, baryon, etc. So these are fermions. That means these all particles, leptons and baryons, are integer spin particles. Next classification is bosons. Bosons can be divided into mesons and gauge bosons or field bosons. So mesons are spin zero particles. Spin zero mesons are there. So example, pions, tions, rho mesons, etc. And field bosons or gauge bosons are gamma means photon, W boson and Z boson. So this is one classification based on the spin of the particle. Two categories, fermions and bosons. Fermions again divided into leptons and baryons. Similarly, bosons can be divided into mesons and gauge bosons. Next category based on their interaction with a strong force as leptons and hadrons. That means classification of particles based on their susceptibility to strong force or their interaction with strong force. So that classification is two types, leptons and hadrons. So leptons are the particles unaffected by strong force. Leptons are unaffected by strong force. Leptons are unaffected by strong force. Hadrons is another category, and here these are affected by strong force. Hadrons are affected by strong force. You can see that leptons and hadrons are the Greek words. Leptons, the Greek word lepton means light or swift, like that, and then hadron means heavy or strong. So the particles are categorized into leptons and hadrons depending on whether they respond to strong interaction or not. So if the particles are responding to strong interaction or affected by strong interaction, then that particles are known as hadrons. And if a particle is unaffected by strong force, then such particles are called leptons. Okay. So again, we can divide these leptons and hadrons into different types. So this is the general classification of elementary particles. So the classification based on spin, fermions and bosons. Fermions are spin half integral spin particles. They can be divided into leptons and baryons. Leptons, in the lepton family we have 6 members: electron, electron neutrino, muon, muon neutrino, tau neutrino. Don't worry about that, we will discuss in detail about each family in coming classes. Okay, so in the lepton family we have 6 members. All the 6 members are elementary particles. Okay, electron and all neutrinos are basic elementary particles, and they are stable particles. Muon and tau are not. Mu and tau particles are not stable particles. They can decay into tau can decay into mu can decay into electron. So electron and 3 neutrinos are stable elementary particles. And we can come across several other properties of leptons. Okay, later. Next family is baryon. So baryon can be again divided into nucleons and hyperons. Nucleons are familiar to us. Nucleons are the members of nucleus. So what are the members of nucleus? Proton and neutron. So proton and neutron are combinedly known as nucleons. Next category is hyperons. In the hyperon family, there are several members. We are only interested in these particles. Lambda particle, it has neutral charge. Then sigma family has sigma plus, sigma minus and sigma 0. Next one is psi. So this is named as psi. So this is lambda, sigma, psi. Psi family consists of two members, psi minus and psi 0. And last one is omega. So these are the members of baryon family. So baryon family consists of nucleons and hyperons. Nucleons contains protons and neutrons. Hyperons contains lambda, epsilon, psi and omega. Lambda 0 is a single particle having neutral charge. Sigma family consists of sigma plus, sigma minus and sigma 0 members. Psi family consists of psi minus and psi 0 members, and omega minus is a single particle. Okay. Next classification is boson. So bosons are integral spin particles. They are categorized into two classes: massless bosons and mesons. Mesons are spin 0 particles, and massless bosons are spin particles having spin. So massless boson category, we have two classes for two particles, photons and gravitons. Both are massless bosons. They have no mass. So photons have spin 1 and graviton has spin 2. Now mesons are categorized into pion, cation and eta. So this is known as eta. Pi is known as pion. K is denoted as cation. And eta is named as eta. Okay. Here electron. This mu is known as muon. And this tau is known as tau. Okay. So pion, cation and eta mesons are the members of meson family. In this, pion can be again divided into, or pion family consists of pi plus, pi 0 and pi minus. Cation family consists of K plus and K0. Okay. So this is the classification of elementary particles. Okay. So by considering each family, we can discuss in detail about each particle. Okay. So this is an overview of classification of elementary particles. So we have classified particles based on their intrinsic spin. So based on the spin, we have two types of particles, fermions and bosons. So fermions obey Fermi-Dirac statistics and bosons obey Bose-Einstein statistics. Fermions have odd half-integer spins. That means half, 3 by 2, 5 by 2, etc. Bosons have integer spins. That means 0, 1, 2, etc. Fermions obey Pauli's exclusion principle. That is another significance of fermions. What do we mean by Pauli's exclusion principle? You are familiar with that principle. This principle asserts that two identical fermions cannot occupy the same energy state. That means two fermions. Pauli's exclusion principle is generally stated in terms of electrons. No two electrons can occupy the same energy state. Similarly, we can generalize it into fermions. So what do you mean by what is the statement of Pauli's exclusion principles? That means two identical fermions cannot occupy the same vicinity, or means same energy state. That principle is known as Pauli's exclusion principle, and fermions obey this principle. But bosons do not obey Pauli's exclusion principles. That means any number of bosons can occupy a particular energy state. More than two bosons can occupy, more than one boson can occupy a particular energy state in the case of bosons. Okay, that means they do not obey Pauli's exclusion principle. Next important point about fermion is that the particles that build up the matter in our world are fermions. Example: neutron, proton, electron. Using all these particles, we are building up the matter. Okay, but in the case of bosons, particles carry the basic forces, and that particles are called all particles carrying basic forces are bosons. That bosons are known as field bosons or gauge bosons. So field bosons or gauge bosons have the feature that they carry the basic forces or basic interaction. Example: photon is the carrier of gravitational interaction, gluon is the carrier of strong interaction, a weak boson or W boson is the carrier of weak interaction, and graviton is the carrier of gravitational interaction. So these are the comparison of fermions and bosons. Next is the comparison of hadrons and leptons. We have already discussed that hadrons are the particles always affected by strong force, and leptons are the particles unaffected by strong force. Next one, hadrons can interact through strong, weak or electromagnetic interaction, while leptons can interact only through weak or electromagnetic interaction. Of course, gravitational interaction is here. Gravitational interaction is common to all particles. So I am not mentioning gravitational interaction here. Gravitational interaction is applicable to all particles. So we need not mention it specially. So here, considering other three interactions, we can say that hadrons can interact with all interactions, while leptons can interact with all interactions except strong interaction. Okay, so I think that is clear to you. So hadrons are the particles, or hadrons interact through all interactions, while leptons can interact through all interactions except strong interaction. Now, in the case of hadrons, they occupy space and have internal structure. That means we can split them into still smaller particles. But in the case of leptons are truly elementary. That means they have no internal structures. They are structureless, so we cannot split into smaller particles. That means they are truly fundamental or elementary particles. We can classify hadrons again into baryons and mesons based on their spin. All the leptons have spin half, while in the case of all hadrons are not same spin. They are categorized into two classes, baryons and mesons, based on their intrinsic spin. Now, the baryons are fermions, and baryons again consist of three quarks, while leptons are fermions and they are stable. They cannot be divided further into any other particle. Next one is mesons. Mesons are bosons and consist of a quark and an antiquark. So these are the main difference between strong interaction hadrons and leptons. Hadrons are affected by strong force and leptons are unaffected by strong force. Now, in the case of leptons, all leptons are spin half and all leptons are fermions. So you have to study this comparison between hadrons and leptons, and similarly the comparison between fermions and bosons. So today we have discussed about the classification of elementary particles. What do you mean by an elementary particle? What are the characteristics of elementary? What are the characteristic properties of elementary particles? Classification based on spin and based on their response to strong force. Okay, so based on that we have this classification, and we have compared fermions and bosons, and like that we have compared the difference between hadrons and leptons. So in this class we have discussed all about the classification only. So in the later classes, in the next sessions, we will come in detail about each family. Okay, so you have to familiarize each family and the members of each family for tomorrow. Okay, so classification based on spin, fermions and bosons. Fermions divided into leptons and baryons. In the lepton family we have 6 members, and in the baryon family we have a nucleon and hyperon. Nucleon can again be divided into proton and neutron. Hyperon can be divided into 4 other members. In that also we have further split ups. Okay, and similarly in the case of bosons. So study well this classification, and this classification and the knowledge of members in each family is very important for the next class. So for the next class you have to study this classification thoroughly. Okay, thank you, and ask your doubts if any.